In this video, we'll just continue looking at adding fractions using common denominators, and we'll just do a couple sample questions. Let's try 2/3 plus 3/5. Okay. So what I need to do is I need to find a common denominator between 3 and 5. The easiest way for me to do that is to multiply 3 times 5, and that gives me 15. So my new denominator is going to be 15. But I still have to figure out what my numerators are going to be. Looking at this fraction first, I had to multiply 3 times 5 to get to 15, so I've got to do the exact same to my numerator. I've got to multiply 2 times 5, and that's going to give me 10. So my first fraction is 10/15. And the other side, I had to multiply 5 by 3 to get to 15. So that means I also have to multiply my numerator by 3, which is going to equal 9. So my fraction is going to be 9/15. Now, it's kind of cool because I can look back and check. My original fraction is 2/3. That means 2 pieces out of 3. Now my fraction is 10/15. If I think about it, I have 3 pieces of 5 that can go into 15, and 2 pieces of that would be 10. 5 plus 5 is 10, so 2 pieces of 15 is 10 if I put them into fifths. Just to get the final fraction here, I'm going to add these together. 10 plus 9 is 19, and my denominator stays the same at 15. Now what I've come up with here is I've come up with an improper fraction, meaning a fraction where the numerator is larger than the denominator, and later on I'll look at how I can fix that. But that's not a surprise, because if I look at it, I'm adding 2 numbers here in 3/5 and 2/3 that are larger than a half. If those numbers are larger than 1/2, that means that I'm going to end up with more than 1 as my final answer, and that means a fraction where the numerator is larger than the denominator. And that's okay. Down here, let's try a relatively small fraction. Let's try 1/8 plus 1/4. These are relatively small fractions compared to the ones we just looked at. This is kind of cool because if you notice, I don't have to find a common denominator because I already know a multiple of 8 and 4, and that's 8. 8 times 1 is 8. 4 times 2 is 8. I don't have to even change this denominator here. So what I'm going to wind up with is that I'm going to wind up with fractions that are 8ths. And that saves me a little time, but just to keep it in mind, I have to keep in mind that I did do 8 times 1. I didn't just leave it alone. I did 1 times 8, and that's a multiple of 8, which means also on the top I multiplied by 1, and 1 times 1 is 1. So that fraction looks the same because I've only multiplied by 1 times 1. Here, to get from 4 to 8, I have to multiply the denominator by 2, which means I also have to multiply the numerator by 2, and 1 times 2 is 2. So I've wound up with 1/8 plus 2/8, and that final fraction is going to be 3/8. And that does make sense if I look at it, because 1/8 is a very small fraction, and 1/4 is not very much either. So I'm winding up with a relatively small fraction in 3/8. So I can feel confident that I've done this one correctly.